This is Knowledge Engineering with Semantic Web Technologies. And this is the very last part, the very last extra part of the second lecture, RDF-based knowledge representations. And in this part, we want to focus on the question, how does the RDF data that we already know, for example, from Sparkle endpoints or somewhere in datasets in the net, how does this combine with the web of documents, so with the World Wide Web that we already know? So how does RDF get into the World Wide Web? Yeah, so we are here talking about formats, which are here on the format level. So we will talk about RDFa and so-called microformats. So, of course, the W3C gives you several possibilities to include data like RDF into your web document. So first of all, RDF XML can directly be embedded in an HTML document, so via the head and the script directive. So in RFC 3870, you will see a MIME type which is called application RDF and XML. And with this MIME type, you can define a script like you see here in this encoded HTML file. And here you can, with the RDF XML serialization, include RDF directly into a document. So what else or what other possibilities do you have? So the W3C recommends explicitly the linking of external RDF documents via the HTML link element within the header of an HTML document. But also you can refer to a linked dataset, a linked RDF dataset within the body of an HTML document simply via the href attribute of an anchor identifier. Like you see that, so like you define a hyperlink, simply you can also, of course, refer to an RDF dataset and make somehow in the document known that this link here hides or goes to the data of an RDF dataset. So this could be two possibilities. But this possibility where you explicitly reference to another file which is at some other position in the web, this is not necessarily always, let's say, the best possible solution, because you have to maintain two different files. And usually you can think of, if you change one of the files, possibly you also have to change the content of the other file. So, for example, in your web shop, if the price of something here changes and you make the change on the HTML part, then also, of course, this change has to be done in the RDF description of your products in another file. So maintenance might become a problem. Also, the verification, is this really somehow correct, and is there a consistency between the presentation in the HTML file and the data in the RDF file? So this is always a little bit complicated if you do not really intertwine both of these representations. So what we are looking for is, we are looking for a way how to directly put RDF into an HTML file, but not necessarily like in the first case at a completely different position, but exactly at the place where you need it. Okay. And there are three possible solutions we will talk about today. So the first way to do that, to bring structured information somehow into the World Wide Web, can work via so-called microformats. The second way can work via so-called generic RDFa. So this is, of course, the preferred way, because this is a semantic web-based language. And of course, you can really bring semantic annotation, free semantic annotation into the web. And another way can also be so-called HTML5 microdata annotations. And to these microdata annotations, one of the most prominent one is the so-called schema.org, which you have probably already heard of. Okay, so let's start with the first one. We look at the so-called domain-specific microformats. Microformats are now about 10 years old, so they emerged about 2005, and they are able to express limited semantics within an HTML document, and you use therefore XHTML markups usually. They are designed to solve rather simple, specific problems. They are, in the first case, designed for human usage and not necessarily for machines. And usually they are used in web pages to describe a specific type of information, like, for example, to describe a person, to describe an event, or describe a product, or to give a review about something. The nice thing is, of course, microformats can easily be extracted from HTML document, and they are encoded within the document by usually using attributes. So they use, for example, the class attribute in HTML text, and most probably they are using specific texts which do not have a real formatting result in the HTML page, like, for example, div or span tags. So usually attributes like class, rel, or ref are used here for HTML or XHTML tags. And there are some predefined standard microformats already available. So the most prominent is HCard for personal data. So this is vcard, and there is already existing an RFC for that. Then for dates and calendar events, you have hcalendar. Then for tags, keywords, and categories, there are the so-called rel tag microformats. Then for social networks, so for friends networks, there is XFN, and for options, ratings, and reviews, you have hreview or vote links, and then there are even more. The interesting thing here is, for example, HCard and hreview are microformats that are also used and read and analyzed by Google already since 2009 and by Facebook since 2011. So they are, of course, of a certain importance. Okay, let's have a look how these microformats work. So, as we already said, one of the attributes, the class attributes, most times is used. So you see here in a bunch of div and span attributes tags, the class attribute, and the class attribute here is assigned a variable name. So first we say, okay, this is the class vcard, and then we say, okay, so all the content which is embedded by this div tag then is the vcard. Then there comes the next tag, a span tag, and all the content which is embraced by the span tag here is then fn, which is the first name, which is here Joe Blow, and then the next one is a title, and then you have an organization, an address, and so on and so on. The nice thing here is, of course, the content, of course, is displayed in the web, so the name, also the title and the organization that you see here is displayed, but within the attribute of the span tag, there is a binding to a so-called microformat variable that you see here. So this can easily be extracted. And on the other hand, if you change your HTML document, of course, you do it exactly at the place where also the definition of the data, the microformat data is. So this is, of course, a nice thing that you see here. But keep in mind, microformats only exist for a few or a rather small number of things or specifications. And this, of course, yeah, it has a reason. So there are certain pros and cons for microformats. So the first thing is, of course, microformats could be easily transcoded to RDF. So you can read it somehow via, for example, with an XSL transformation style sheet. And then you can transform, if this is XHTML, you can transform the microformats directly if you want to RDF. So this is no big deal. The problem is you are not free. There are predefined microformats. And if you want to introduce a new microformat vocabulary, this first must be consolidated by the community. And of course, also another XSLT style sheet has to be developed for the extraction of exactly that microformat. So this is one of the drawbacks. Another thing is, of course, if you're using more than one microformat vocabulary in a single HTML document, this might get mixed up, and then of course the complexity of processing this and analyzing this might really increase rapidly. So this might be cause of a conflict, and another cause of a conflict might be that, of course, already existing attributes are mixed up with attributes that are used as microformats. So here we might end up in another conflict. So these are drawbacks, and these drawbacks, of course, are addressed in the other formats we will talk about, which are a little bit newer, and which are RDFa or then so-called HTML5 microdata. So first, let's start with embedding real RDF within HTML attributes. This is RDFa. So RDFa is nothing else but RDF in HTML attributes. So the basic idea is exactly the same as for microformats, and it enables generic RDF annotation within HTML or XHTML documents by reusing XHTML attributes. First version of RDFa was based on XHTML, but XHTML, as you might know, has been substituted by HTML5, so therefore there is also a new definition for RDFa, so now it's RDFa 1.1. And this, of course, is then for HTML5, and there is also a small version which is called RDFa Lite, which we'll look on first, and then a full-flexed version called RDFa 1.1. So let's first look at the lightweight version. So here we are reusing specific HTML attributes like the href or source attribute, with which we denote usually URIs or links to URIs. And we have a few new HTML attributes that are introduced here: the vocabulary attribute, type of attribute, property, resource, and prefix, which are not part of the usual HTML syntax, but have been introduced with RDFa, and therefore first no conflict with already existing attributes of HTML might occur. Okay, so we start with a small example. If we want to talk about something, so here, for example, I want to create a small web page where I somehow include my name and my phone number. So first, I have to specify which kind of vocabulary I use. So here, for example, this information I can perfectly encode, so it's personal information, with the FOF vocabulary that we already know. So first, I say everything which comes now in this paragraph, that will be addressed via the vocabulary FOF that I specify exactly here with a vocabulary attribute. Okay, first I define the vocabulary. Next thing, I have to state about what we are talking. So in this vocabulary, certainly specific classes might occur, and here I'm talking about me as a person. And in the fourth vocabulary, there is the class person, so therefore I can here state that the type of the information which is embedded here in the paragraph attribute, this refers to a class of type person. So I use the type of keyword and say this one is a person. And person, of course, is a class from the fourth vocabulary. So I have the namespace right above. Okay, so I have the vocabulary and I already say about what I'm talking. So I have a type definition. Then I can make use of properties from the vocabulary I have specified. So therefore I have, for example, the fourth name property. Then I introduce a new tag, a span tag, that has no effect in the end on the formatting or the presentation result of my web page. So I put my name into the span tag and say as an attribute in the span tag that this is the property fourth name. And then I do the same with the phone number here, for example, and I say, yeah, the phone number is embraced by a span tag with the attribute fourth phone. And then, for example, I can also add another image, for example, in the HTML page, and I say, okay, this is an image and this is an image of me. So therefore, I encode it with the property fourth image. So with this, I can already introduce a lot of RDFa information which can be extracted and directly transformed into RDF, because here are statements made about something which is encoded within the given paragraph, and we know already that this is a person, this person has a name, this person has a phone number, and this person has an image. That's quite nice, isn't it? Okay, we can already do more. Of course, we can say the thing we are talking about must not necessarily be or does not necessarily have to be a blank note. Of course, I can give this resource also a name and a URI. So therefore, I specify what I'm talking about in this paragraph tag. I give this a URI, and I say, okay, this then might have the URI Harald. So I use here relative URIs because always the base URI of my HTML page here is used to complement relative URIs. So that's quite nice and quite simple. Okay, so possibly one vocabulary might not be enough. So like usually in RDFa dataset definitions or data definitions, I can use more than one prefix, and therefore there is also the attribute prefix with which I can define a new prefix for an alternative namespace. So here, for example, I also introduce a namespace from Open Vocabulary, because the FOV namespace does not offer also to denote what is my preferred beverage. This is, for example, possible with the Open Vocabulary, and therefore I add to the paragraph I have here, my favorite beverage is, and then I introduce a span tag with the attribute preferred beverage, which stems from the Open Vocabulary. So the prefix for this I have defined right here, it's OV. So therefore OV colon preferred beverage, and then I have the content of the tag, which is green tea and which denotes as a literal my preferred beverage. You see, using RDFa, it means using RDF directly in the attributes of an HTML document, is really quite simple. Okay, this was RDFa Lite. So what else is there hidden in the full-fledged RDFa 1.1? So first of all, what RDFa 1.1 offers me is I can separate, if I want to, between content and presentation. So what does this mean? So just look at this small example. Again, I have a paragraph where I use a vocabulary. This time I use the Dublin Core vocabulary, and I use Dublin Core terms, and I say, okay, the title of the things in this paragraph will be syllabus of something, and I will say the creator of this is somebody, so it's me usually, and I say I have a creation date, and then I see the creation date I have written here as the 28th of October 2012. But this here is only the representation within the HTML document. So this would not be a valid date or a date formatted accordingly to a valid expression in RDFa. To do that, I can, for example, here separate the content which should be used when creating a triple within the span tag. So I use here the property created from the DC terms vocabulary, and I say the content of that triple should be what is then here expressed after the attribute content. And there I can specify a literal as it should be interpreted in the RDF triple, which will be extracted here from the HTML document. So I can separate the presentation, which will be displayed in the browser, from the content, which then will be used as a data item within the RDF that is extracted from the RDFa embedded in that HTML page. So this is the first thing what I really can do. I can separate content from presentation. Next interesting thing what RDFa 1.1 offers me is I can use data types. So here, for example, I can state that here the year that I specify, 2012, should be interpreted as a year. And I can here specify the XML schema data type namespace. And you see here accordingly, this then will be interpreted in the RDF triple that results from the extraction here as a year. So it's a date-based expression. Okay, but there are more differences, and of course it's getting more complicated whenever I do a more complex nesting of these expressions. So here we have an interesting example. So we have resource, which usually denotes a URI, and we have object. We have the resource, and then there is the so-called attribute, which is called about. And they are used almost in the same way, but there is a slight difference. And the difference I will explain now to you. So first of all, if I want to address a URI within an attribute, and if I want to talk about something which is expressed via URI, I use simply here the resource attribute. So in this div tag block that I see here, I'm talking about a resource which is called Alice posts trouble with Bob. So this obviously comes from a blog or something like that. And therefore, for that resource, then within the div tag block, I define certain properties which then in the end define triple statements, RDF triple statements. So for example, I define that this subject has the property title, which is Trouble with Bob, and it has a creator, which is Alice. And the point is, here I can use resource on the one hand as a subject, so it defines the context for everything which comes after that. But if I use resource together with a property within the same tag that you see here, if I use both properties at the same time, here you see creator, property creator, and resource is me, then the resource will be interpreted as an object. So resource defines or denotes a URI, a resource, which can be, and this depends on the context, interpreted in different ways. It can be interpreted as a subject of an RDF statement, like you see it here. Then it stands usually alone in a tag attribute. And if it's used together with the attribute property, then usually it's interpreted as an object. And this, of course, might cause trouble. Just look at the following example. So this is an unordered list. And in this unordered list, I define a resource. This is again the blog post Trouble with Bob. And there I have list items in this HTML file, and each of these list items is formatted in exactly the same way. I also define again a resource in each list item, which defines a blog post, and then I define for this resource a property, which is here always the title, and then the content of that property, which is a literal. So far so good. It's a little bit convoluted as the slide says here, but this works. The problem is if I now want to make this a little bit shorter by including also the property into the list tag, of course, everything changes the meaning. And then, of course, this does not make sense anymore, because then, of course, the property that I see here always refers to the only subject that is given here within the attribute resource of the unordered list. And the former object, which was a literal, now becomes the object which is given within the list tag as resource, and which becomes a resource and is not a literal anymore. So combining here resource with the property changes the semantics accordingly. So this is not correct anymore. If I want to format it in that way that I want to include both attributes within a single attribute here, and I nevertheless wanted to treat the resource as a subject, I have to use another keyword. I have to use about here. So about, in difference to resource, can never be an object. About always refers to the subject. So it always sets the context of a statement. And then, as you see here, if you use for the list items instead of resource the keyword or the attribute about, then it's interpreted correctly. And then, of course, the meaning is the same as the first one. And it's not as convoluted as in the first place. So this is the difference between resource and about. So in general, if we look at RDFa, then there are two different kinds of triples, of course, are here distinguished. First, we have triples with resources as an object, and we have triples with literals as an object. And what kind of attributes do I use? So first, let's have at the object is a literal. Of course, the subject I'm talking about, I can use resource or about. Then the property, I can use the property attribute, and for the object, either I use the content attribute when I want to separate content from presentation, or I use the parsed data from the HTML file, which is embedded in the tag where I have used the property. Okay, and if the object is a resource, it's more easier, so I can use as a property either property, or I can also use rel, which stems from RDFa 1.0 and is some legacy attribute that can also be used. And then as an object, of course, I can use resource, or I can also refer to an object by a usual HTML href link. So in this way, RDFa is encoded within HTML files, and this of course is pretty handy. So just have a look at the old version, RDFa 0.1. So of course, XHTML is still around out there, and therefore, of course, we are talking about an HTML file which is encoded in XML, and therefore, of course, if you want to introduce or include RDFa, it's very similar, but here, of course, you use a namespace from XML namespace definition here in your div tag, for example, where you define elements from Dublin Core, and then I can define in a span, instead of resource, I use about. This is also a legacy term that we know. It's like the resource, so it defines the subject, and then I have property for the property, and then I can here, if I'm talking about triples that have as object a literal, I can simply pass what is the content of the surrounding tag. So this is interpreted in a nearly similar way. The only difference is, of course, if you have an XHTML file, an XHTML file, this is basically an XML file. And therefore, of course, the namespace definitions work a little bit different. And of course, you have to give another version of RDF when you are working with XHTML. So RDFa 1.1 works with HTML5, and RDF 1.0 works with XHTML, which is XML-based HTML. So this is the header of both, and you see here what kind of namespaces you have to use in either case. Okay, so we have already talked about microdata, we have talked microformats, and we have talked about RDFa, of which, of course, RDFa is the preferable way to define generary or arbitrary data on the web. Another way are the so-called HTML5 microdata definitions. So microdata in general extends microformats as we already know them and addresses all the shortcomings we have talked about. And the most prominent of these microformats that exist is schema.org, and we will talk about that shortly. So what microdata does, it annotates the domain object model of the HTML file with so-called scope name value pairs for custom vocabularies. So you can define custom-made vocabularies, and they can be used for annotation. In the same way as for RDFa, there are global attributes, new attributes defined. So first of all, there is an item scope, for example, which creates a resource. So we know that like a resource, for example, in RDFa, then you can give a type definition with item type. You can define a unique identifier with item ID. You can define a property with item property, and you can give references to other resources with item ref. So this is really very similar to RDFa. And there exist already a huge number of microdata formats. You can look them up here at datavocabulary.org, and there are vocabulary, for example, for persons, for events, organizations, products, reviews, breadcrumbs, apps, and so on and so on. So there is a lot of vocabulary available. In principle, then it looks like that. So here, for example, we have annotated, again, some personal information with the help of microdata. And you see here, for example, we use as item, or we define an item scope here, which is here given in that section. And then we have the item type, which is a person, which means we use here the vocabulary, which is called datavocabulary.org/person. And then we have the property name, the property title, the property affiliation, and so on. So you see here that you can define for the content of your HTML file, you can define specific properties and specific types. And as you can imagine, this also can, of course, pretty easily be translated into an RDF-like representation. So what happens if, for example, an application on the web comes to a file that also includes microdata? This then, of course, can be interpreted, and the microdata can be extracted. And you can, for yourself, try out the extraction of microdata from a given HTML file. So there are interesting webmaster tools available, for example, here at the Google Webmasters website. So the link is here. And if you there, for example, give the URL of a website, or you give specify the copy paste the entire code that you have here, then you can extract the structured data that is given within the HTML data. And you see here, for example, the structured data that was given in our HTML example. You have here a table with the person name, the person title, the person affiliation, and so on and so on. So what can be done with this structured data? So let's first have a look at the most prominent example, which is schema.org. And this is, of course, a kind of vocabulary which has been defined by the three major search engines, Bing, Google, and Yahoo, back in 2011. And it defines a semantic markup for web page content based on, again, proprietary HTML5 microdata schemata. And the nice thing is, of course, search engines as well as web crawlers and browsers, they can recognize these HTML5 microdata. They can understand the markup, and of course, then they can act upon the results they achieve from that markup. So they provoke some reactions, and you can do more sophisticated things than otherwise if you only had to interpret the text that is given in a document. So let's have an example. One of the examples, you know that from search engines, are the so-called rich snippets. So what is a snippet? A search engine snippet, so this are a few lines of text that usually appear under every search result that you get from a search engine, for example. And it should give the user some sense of what is going on within the web page that is behind the link to that result. So in former times, of course, there were only a few text lines. But what you know now, if you're now searching with Google or Bing, you will see some so-called rich snippets. You can see rich snippets whenever there is some microdata available within the website it refers to. So with rich snippets, you can give detailed information intended, of course, to help the user with specific tasks or queries. So for example, here with the books you have here, there for the description of these books, of course, a specific vocabulary has been used, which is available at the schema.org vocabularies. And there, of course, you can, for example, directly refer to the price, and you can make price comparisons, for example. You can refer to votings which are given here, and you can compare books according to their voting, for example. And this, again, also the availability in a certain specific store, for example, can be evaluated. And then, of course, your search result can be refined according to the price of products, to the availability of products, or to the quality of a review of a product. And this, of course, is really a quite convenient thing to do, because this is only possible if the search engine really understands the content of the web document. And here with HTML5 and schema.org, it's possible because we are using here a vocabulary where everybody has agreed upon what the vocabulary really means, and it's only a rather limited vocabulary that is used here. So what you can do with schema.org, you can apply a limited set of annotations in difference to RDFa, where you can define your own annotations and can make this rather more generic than in the case of microdata. So, if we look at the web today, what can we say about the microdata usage? So how many websites do really use this kind of structured data within the HTML pages? So it's always quite difficult. So there was a survey in 2014, which is the latest number that I have, and this is here from the webdatacommons.org crawl, and they are using a web crawl which is called the Common Crawl Corpus, which consists of 2.3 billion HTML pages which have been gathered by a web crawler and parsed. And within these pages, more than 500 million contained RDFa, microformat, and microdata. So this is more than 26% of all these pages. And these numbers are growing. I have another number for you. In 2012, also Yahoo, also one of the major search engine companies, made a crawl. This crawl consisted of 3.2 billion HTML pages which have been parsed, and they are available in the so-called Bing crawl corpus. And there they discovered more than 900 million pages which contained RDFa, microformat, and microdata annotation. So this is quite a lot if you look at the overall number of all available pages on the web. But you might agree with me that not all of the 30 or the 3 million web pages, 3 billion, in fact, web pages that have been analyzed have the same importance. Of course, we, for example, have to look at the major websites and if they are using really also this structured data on the web. So what they did in their analysis here was they also looked at the top K Alexa websites. So these are the top K important websites according to this web platform Alexa, who analyzes the performance and the popularity of websites. And there you can see, so if you look at the first two columns, in the first column there is always the number of the first K in Alexa, so the first 100, the first 1,000, the first 10,000 most popular websites. In the second column is the coverage of the corpus that has been addressed here. And you see here from the first 100 of Alexa in the corpus, there were already 99 websites. Or from the first 1,000, there were 963 websites and so on. So this means the crawl does not cover the entire Alexa websites, but you see here it covers quite a lot. And the interesting thing here is if you look at the first 100 websites in Alexa, you see that overall 75% of them are using RDFa microdata or microformats. So even 34% or more than 34% of them are using RDFa. If you look at the first 1,000, the numbers even get better. So you have overall 62% and 40% of these websites are using RDFa. 31 or almost 32% are using microdata. So you see the coverage at most, or this is important, at least in the most important websites that we have here, of structured data like microformats, microdata, and RDFa is increasing. And this, of course, is a good sign that semantic web technology and also linked data technology, especially linked data technology, is on the edge of becoming mainstream here. So because if you use it, you clearly get a benefit. At least your search engine interprets this data, and then if you compare your search result with the search result of a competitor who does not use microdata, of course will not have the same performance within the search engine. And this, of course, is a reason for using this kind of microdata. So you see, there is a very simple possibility to embed semantic data with the help of RDFa, for example, also directly into web pages. So what we are doing here is not strictly academic, but you can really use it also in a daily web-based environment. And of course, with the tools you see here and the tools that are linked to in your materials, you might be able to roam around and to browse around and to find what kind of microdata resources are out there in the web. Okay, and this closes the third and the last extra part of this second lecture, which was RDFa-based knowledge representation. In the next lecture, we will talk about ontologies and logic, and then what we are doing with the kind of structured data that is available on the web will get much more sophisticated, because then we will also be able to make logical deductions and entailments based on the data that is here to create new data, which we deduce or infer from already available data.